Good day everyone. Today we're going to talk about the soil formation and development. Introduction. This section introduces the concept of soil as a dynamic entity which is constantly changing over time. It emphasizes the integrated effects of climate, living organism, parent material, and time in shaping soil properties. In Jenny's widely accepted hypothesis, identify these factors which are the climate, organism, relief, parent material, and time is presented. The importance of parent material, especially during the early stages of soil development, is one of the most influential factors. Parent material is in soil science refers to the underlying geologic material characterized generally by the bedrock or can also be from previously deposited material. Three types of rocks are identified on Earth's surface according to the major earth processes that form them, namely igneous, metamorphic, and sedimentary rocks. They can also be classified based on their chemical composition as either a mafic type, where it contains higher amounts of magnesium and iron, or a felsic rock, where it is enriched with lighter elements, particularly silica. But oxygen, silicon, and aluminum make up of 82.43%. Thus, quartz, which is one of the most abundant minerals, is made up mainly of silicon dioxide. The so-called silicate clays minerals are composed chiefly of silicon, oxygen, and aluminum in various proportions and combination with different elements, usually basic cations such as potassium, calcium, magnesium, and sodium.
So what comes in your mind when you hear the word mineral? So mineral, it is a naturally occurring inorganic substance with very definite chemical composition and specific physical properties. Mineralogy, it is the study of minerals and their properties. So mineral in simple definition, it is a natural substances found in the earth. For example, gold, salt, and diamond. When we say primary minerals are those that exist in their original states and are very resistant to decomposition. So, primary minerals, ito yung mga matatagpuan sa original nilang anyo at hindi pa sila nagbabago o naaapektuhan ng mga iba pang proseso. Sa secondary minerals naman, it arises from the chemical breakdown of the least resistant primary minerals. They are created over time as the original minerals break down or react with the environment. Secondary minerals forms when primary minerals change due to weathering, water or other natural processes. Let's proceed to the classification of rocks, but first let's define what is rocks. So rocks are consolidated aggregate of one or more minerals. Petrology is the study of rocks. So rocks are all around us. They make this famous Marag Rock Formation, Monacoto Underground, and others. They can be small or big. Rock is a solid, naturally occurring and is made up of minerals or minerals-like matter that can be divided into three basic types of rocks. These are the igneous rocks, sedimentary rocks, and lastly, metamorphic rocks. Igneous rocks are original rocks formed from the solidification and crystallization of magma at temperature of 900 degrees Celsius to 1600 degrees Celsius within or outside the Earth's crust. They are considered the mother of all other rocks. So igneous rocks are formed when magma or molten rocks cools. This magma can either flow to the surface of the earth. These are the common soil-forming igneous rocks. Next is sedimentary rocks. These rocks are formed from the accumulation of sediments derived from the weathering of existing rocks through fragmentation, transport by water, and recementation. So, sedimentary rocks formed from pre-existing rocks or pieces. Once living organisms, they form from decomposition that can accumulate on the Earth's surface or under the ocean. These particles from the sedimentary rocks are called sediments. These are the important soil-forming sedimentary rocks. Lastly, metamorphic rocks. Metamorphic rocks are formed from other existing rocks through the process of remelting and recrystallization under high temperature and pressure. These metamorphic rocks are rocks that change over time due to heat, pressure, or chemical processes. This change can happen to existing rocks, turning them into a new type of rocks with different properties. These are the typical metamorphic rocks.
Relative abundance of rock. The Earth crust is primarily composed of igneous and metamorphic rock, around 95%, with sedimentary rock like shale, sandstone, and limestone making up a smaller percentage. Two modes of rock formation. First, extrusive or volcanic. Formation is when the magma is ejected out of the Earth crust through volcanic eruption. And the second is extrusive or plutonic. Formation is when magma solidifies with the Earth crust due to still high temperature. Cooling is slower so that there is more time for the crystal growth of the magma. The rock cycle. Rock in the crust are transferred from one type to another. For example, an igneous rock may be transferred into sedimentary rock through weathering and lithification, or into metamorphic rock by partial melting through the action of heat, pressure, or chemical action. On the other hand, a sedimentary or metamorphic rock may undergo complete remelting and crystallization to form an igneous rock. This continuous process through which old rocks are transformed into new ones is called rock cycle.
Everyone, I am Umayam. Today, I will be discussing an important geological process that shapes the Earth's surface, the weathering and soil formation. So, what is weathering? Weathering is the physical and chemical breakdown of rocks and minerals. It is a combination of destruction and synthesis, where rocks first break down physically into smaller fragments and eventually into the individual minerals they are composed of. So, there are two types of weathering, the physical weathering and chemical weathering. So, let's define it. Physical weathering. Physical weathering, also known as mechanical weathering, is the breakdown of rocks into smaller pieces without changing their chemical composition. This process occurs due to various factors such as number 1. Temperature changes, where rocks expand when heated and contract when cooled. Repeated expansion and contraction cause cracks and breakage. Number 2 is the pressure, where the slow release of pressure into rocks formation causes them to crack. Number 3 is water, wind, and ice, where moving water and wind carry small rock particles that grind against larger rocks, breaking them down. Number 4, freezing and thawing, where water enters cracks into rocks, freezes, expand, and eventually causes the rock to break apart. As rocks break into smaller pieces, more surface area is exposed, leading to faster chemical weathering. So let's discuss the second type of weathering, chemical weathering. Chemical weathering involves the change in the chemical structure and composition of rocks and minerals. It results in the release of soluble materials and the formation of new compounds. There are several chemical weathering processes. First is the hydrolysis. This occurs when water reacts with the minerals, breaking them down into acids and bases. Example, feldspar react to water to form clay minerals and potassium hydroxide. Second is dehydration. Mineral absorb water, causing expansion and a change in structure. Example, hematite transform into limonite. Third is the oxidation. Oxygen reacts with minerals, particularly iron-containing ones, causing rust and weakening of rock. Example, ferrous oxide reacts with oxygen to form hematite. Fourth, carbonation. Carbonic acid reacts with minerals to form soluble compounds. Example, calcite reacts with carbonic acid to form calcium bicarbonate. Last is the solution. The dissolution of minerals in water due to the action of carbonic acid or hydrogen ions, often leading to the removal of silica from rocks. Example is the silica dissolving from rocks into water.
The factors of soil formation. The 5 factors of soil formation are climate, living organisms, relief, parent material, and time. These factors determine the kind of soil that eventually develops in particular place. The 5 factors interact with one another, sometimes masking the influence of other factors, or at the other times enhancing the effect of each other. This principle is stated as S. Soil properties being influenced of C. Climate. L. Living organism. R. Relief. P. Parent material. And T. Time. Number 1. The climate. The two most important of climatic factors in soil formation are the temperature and the rainfall. Temperature, this is refers to the degree of hotness and coldness, while the rainfall indicates amount of precipitation or the rain. The higher the amount of rainfall, the faster is soil formation. Water being a solvent is a principal agent in weathering of materials, hydration, or the hydrolysis. It speeds up chemical reactions and facilitates decomposition. Under conditions of low rainfall, silica and basic actions like the calcium, magnesium, sodium, and potassium. The higher the temperature provided water is sufficient, the faster is the rate of the soil formation because the rate of chemical reaction is faster. Number 2. The living organisms that are involved in soil formation include plants, animals, and microbial life. The accumulation of organic material and the decomposed soil organic matter is one of the major role played by the living organisms. So, living organisms is one of the contributor or have a major role played in soil formation. Number 3, the relief of or topography influences soil formation by its effect on movement and accumulation of water and degree of erosion by water runoff. This is more runoff or less percolation on the steep slopes than on the level or plain areas. Marked horizon differentiation normally occurs on gentle slopes or level areas with good internal drainage. However, if these areas are less or hardly permeable to water, they are likely to be poorly drained or waterlogged. Parent material is the partly weathered, unconsolidated, or broken mineral or organic debris from which through soil which is dissolved. It is the starting points of soil formation or soil at zero time of formation, while the inorganic parent materials are classified into two geologic groups, sedentary or the residual, and transported materials. Residual parent materials are those that develop in plain place that form of the rock below where it is found. Transported parent materials are those which are transported by the various agents such as water, wind, or rise and deposited in other sites where they form soil eventually. So, the residual parent material is transported by the various agents, kagaya ng mga ice or water, yung mga basa yun, etc. Transported parent materials are further classified according to the agent or manner of transport. Those which accumulate from running water, usually streams or rivers, are termed as alluvium. A large tract of the soil surrounding the Cagayan River are the alluvial origin. Material that accumulated is former lake waters are termed lacustrine, and those in oceans are marine. Those that are carried by and deposited by moving glaciers are termed glacial till or the moraine. And those by wind are aeolian, with losses and sand dunes, volcanic ash as examples. Gravity can also be an agent of transport, and the materials so deposited are called collovium. This is because other factors of soil formation may exert greater influence with the passage of time. This is the meaning of the phrase, time nullifies the effect of the parent materials. The most common parent materials of Philippine soils are alluvium, central plains of Luzon and Cagayan Valley, shale and sandstone, limestone, andesite, basalt, and agglomerates. When volcanic eruptions emit the deposit fine dust and ash, which eventually harden, the stratified rock called tuff. Some examples of soil formed from these parent materials are Lipa, Guadalupe, Ibaan, Magallanes, Tagaytay, Novaliches, and Teal series. And last, the time factor. Soil formation refers to the active length of time that parent materials have been subjected to soil forming process. Thus, there are young soils, mature soils, and old soils. Alluvial soils are generally young soils because constant deposition always renews the parent material as the soil progresses towards maturity. The horizons or the layers become more and more distinctly differentiated as development proceeds. More of the soluble components, particularly the bases Ca, Mg, and A and K, are leached out. Thus, while old soils have thick solum, they are generally acidic and are of low fertility. It takes about 100 years to form an inch of soil from bare rock. Example of young soils is the alluvial soils. It is always renous, while the old soils have thick solum and it is generally acidic. And last, mature soil has fully developed and become a relatively stable.
So okay, let's go on soil development. As young soils becomes old soils, soil components undergo various processes: additions, losses, translocation, and transformations. These are pedogenic. Pedogenesis means the study of soil origin and development, processes which bring about soil development. These mechanisms are taking place in each soil horizon singly or in combination at various intensities so that eventually each horizon acquires distinctly different properties from the others. This is called horizon differentiations. Organic matter, soluble salts, carbonates, oxide of Fe and Al, and silicates are common materials that are subject to the four basic mechanisms. The combined effects of addition, losses, translocation, and transformation of materials produce differences in the horizons of the soil profile, changes in color, structure, texture, consistency, and some changes do not take place in each horizon. Imagine soil like a cake. It starts as simple ingredients, but over time, things change. In terms of additions, like adding flour to the cake batter, things get added to the soil like dead leaves or dust. In terms of losses, like baking the cake and some moisture evaporating, things get removed from the soil like water leaching out. And next, in terms of translocation, like spreading frosting on the cake, things get moved around in the soil, like clay particles moving downwards. In terms of transformation, like the batter changing into a cake, things change within the soil, like dead leaves decomposing into humus. All these processes all these processes create different layers in the soil, just like the different layers in a cake. These layers have unique properties, making the soil interesting and diverse. So let's move on processes of soil development. The two major processes which result in loss of materials from the soil body are erosion and leaching. The chief agent in these losses is water. Erosion is the removal of materials from the surface of the soil and their deposition in another location. Leaching is the general term for the washing out of soil materials from the soil body. This process happens more intensively in high rainfall areas. In most areas, iron and aluminum oxide such as gibbsite, hematite, goethite, and limonite are left on the leach soil and serve as indicators that soils have undergone intensive leaching. Imagine a strong wind blowing across a field carrying away topsoil like dust. This is erosion, the loss of soil from one place and its deposit elsewhere. Think of water slowly seeping through a coffee filter, carrying away soluble coffee grounds. This is leaching, the washing out of materials from the soil. The most common material added to the soil is organic matter. Plants constantly undergo the cycle of growing and dying, and they accumulate usually at the soil surface. Humus darkens the soil side from increasing soil aggregation and nutrient storing capacity of the soil. Melanization is the admixing of organic matter to the mineral matter, thereby darkening the soil. This is a transformation process. Mineral matter may also be added to the soil through wind and water. This process is termed as cumulization. The general term for the addition of any material to the soil body is enrichment. When we say melanization, for example, imagine a compost pile. As leaves and other organic matter decompose, they mix with the soil beneath, turning it darker and richer. This darkening process is called melanization. Elevation is the general term for the movement of soil materials from one part of the soil solum to another layer. This process results in the formation of argillic, clayey horizon. Generally, the subsoil clay content becomes higher than that of the upper horizon. Calcification is the transfer and accumulation of calcium carbonate in particular soil horizons. Calcification is the removal of CaCO3 from the soil horizon. Salinization is the accumulation of soluble salts of sulfates and chlorides of calcium, magnesium, sodium, and potassium in certain horizons of the soil solum or soil body. Desalination is the removal of soluble ions in the soil. Alkalization Salinization is the accumulation of sodium ions in the soil. Dealkalization or solidization is the leaching of sodium ions from the zone of accumulation. Sievage is the specific term for the movement of fine mineral particles from topsoil, resulting in the enrichment of clay of B horizon or formation of the argillic horizon. Pedoturbation is the biological and physical mixing of soil materials resulting in the homogenizing of the soil. Podzolization or silication is the translocation of aluminum and iron and organic matter, thereby concentrating the silica in the leach layer. Thus, this process is also classified as transformation mechanism. Laterization or desilication, on the other hand, is the transfer of silica from the solum, thus concentrating the iron and aluminum oxides and hydroxides in the leach layer. This is also called a transformation process. Leucinization is the paling or loss of the dark color of the soil due to the removal or organic matter from the solum.
So let's move on to soil pedon. Soil pedon is studying of soil profile. A soil pedon may be examined. A pedon is a three-dimensional soil body which is the smallest volume of soil material that could be called soil. Conventional way to study a soil profile is digging a pit of at least 1.5 meter deep in the ground or by using road cuts. Evaluation of a soil profile is necessary in order to understand the soil as a natural body. Soil horizons are soil layers that are formed roughly parallel to the soil surface with distinct characteristics produced by soil forming processes. There are two types of soil horizons. One is genetic horizons. Genetic horizons is normally evaluated during the field examination of soil. And the second one is diagnostic horizons. Diagnostic horizons is used for classification purposes. The ABC system of naming of genetic horizons was introduced by the Russian V. Vidokhuchev in 1883. It was improved by the German E. Raman in the early 90s, Bridges 1997. In this system, three kinds of symbols are used. These are capital letter, lowercase letter, and Arabic numeral. The capital letter denote the master horizon. The lowercase letter used as subordinate for the distinction of some specific characteristics of the master horizon, while the Arabic numeral are used to either further subdivide a horizon or an indication of a lithological discontinuity. Master horizons. The O or horizons, surface accumulation of organic matters overlaying the mineral soil. A horizon, composed of mineral soil materials but strongly darkened by organic matter mixed with the mineral fraction. E horizons, usually found below an O or A horizon. B horizon, formed below an O, A, or E horizons and show to evidence of the original sediment or structure.
Transitional horizons. Horizons that have properties of more than one of master horizon. Usually of adjacent ones are called transition horizon. There are two kinds of transitional horizon. Those are dominated by properties of one master horizon but having subordinated properties of another, such as AB, EB, and BE and BC, and those in which distinct parts have recognized properties of two kinds of master horizons, such as EB PE, and BC. Subordinated characteristics within master horizon and layers. Designation of subordinate distinction and features within the master horizon and layers are based on profile characteristics observation in the field and are applied during the description of the soil at the site. Lowercase letter are used as suffers to designate specific kinds of master horizon and layers. Other future example of subordinated characteristic common in the Philippines soils. A. Highly decomposed organic material used for horizon. B. Buried genetic horizon. C. Concretion of nodules. D. Dense layer physical not restrictive. E. Moderately decomposed organic material used for horizon. G. Stagnant condition due to submergence. H. Accumulation of organic matter. I. Highly decomposed organic material. M. Strong condensation or induration. And genetic accumulation of exchange sodium. O. Residual accumulation of residuosides, iron oxides. B. Flowing of other human disturbance. R. Strong reduction. U. Urban and other human-made material. V. Occurrence of print type. W. Development of color of structure. Y. Pedogenetic accumulation of gypsum. Z. Pedogenetic accumulation of salt more soluble than gypsum. Regolith. The loose mantle of weltered rock and soil material above the bedrock. The regolith may be a residual material derived from the weather of rock, or it may be an unconsidered sediments it considered of the A, B, and C horizon. Solum. It refers to the upper part of a soil profile above the present material in which the processes of soil formation are active includes the A and B horizon. Soil monolith. It is a preserved soil profile used for display purposes.